Welcome. So, Andrew, you said that you were a wannabe. I don't know who Michael is exactly, or yeah, I don't know. But welcome, you guys. And then I have two lovely people to heckle, add in things, and assist me, which are Kevin and Josh. So this should be exciting. So this is Intro to Microphones. I'm Ryan. I like to think I know a little bit about microphones. So yeah. All right, what we're going to cover. We're going to cover frequency response, polar plots, and then from the DPA guide, the different microphone placement frequency responses and what those mean for practical application and what you have to do with them. Oh, God damn it. So we're going to start with what is Hertz? Hertz is a thing that I'm going to be referring to a lot in a second here. Sorry. I love it when Google likes to behave. I went to change my slide format and I hit a button I shouldn't have, and it redid all the text boxes. And I thought I fixed all of them, but it turns out I didn't. So what are Hertz? As this chart shows, Hertz is a measure of frequency, which is derived from the number of cycles per unit of time. So that's why the standard measure of frequency is called the Hertz. So if you look at the chart here, let me turn on my pointer. You can see that as this pressure is changing, there is also a time component of, say, for example, the pressure on a microphone diagram becoming positive and then negative, or being pressed in and out. So that takes a certain amount of time, and at different frequencies, it takes a different amount of time because the sine wave at different frequencies is bigger or smaller. So a Hertz refers to the amount of time that it takes for a 360-degree completion of that sine wave. So yeah, that's a sort of half explanation of exactly what's going on. So it's pretty simple to understand the practical implementation, which is the lower the Hertz, the larger the amount of time it takes for one to occur, and the lower it sounds to you. So 1 Hertz is going to be a lot lower than 10,000 Hertz. So for us, we can hear from 20 Hertz to 20,000 Hertz, or what you'll often hear to referred as 20 kilohertz, which is just 20,000 Hertz. And you'll see that some of the microphones that we're going to look at can hear more than that, which can sometimes be useful to us, but often all we really care about is that 20 to 20,000 Hertz, which is why when you look at like an EQ on a mixing console, for example, on digital console, that only goes from 20 to 20. And a lot of these spec sheets will only go from 20 to 20. So yeah, that's what that is. And you'll see how that applies here in a second. So next, we're going to look at a frequency response from microphone spec sheet. This is from an Earthworks M30. So an M30 is an RTA mic, so it's designed to be perfectly flat. And that this is an M30, so it also goes higher than what we can hear. So you'll see that this chart for this microphone frequency response actually goes all the way from 1 kilohertz to 100, or sorry, from 1 hertz to 100 kilohertz, which is way more than we could hear. And the important thing to note when reading these charts is that the resolution of the chart. So here, between 1 hertz and 10 hertz, you'll see that each of these lines signifies a single hertz. So this is 1 hertz, this is 2 hertz, this is 3 hertz is above here, and so forth. But then when you come here, this from 10 to 100 hertz, each of these lines represents 10 hertz. Here from 100 hertz to 1000 hertz, or 1 kilohertz, it represents 100 hertz with each line, then 1,000, and then 10,000. So that's really important to keep in mind when you're reading these charts. And it'll be the same thing when you're looking at the EQ on a mixing console, in that these displays are what's called logarithmic. which means that as you go higher, or it's a form of a logarithm, in this case, as you go higher in the frequency spectrum, higher hertz, it'll show you less resolution because we are less sensitive at those higher frequencies in terms of resolution wise. There's other curves that show how sensitive we are in terms of how we hear things. But we can hear a lot finer resolution down lower, especially in this 100 to 1,000 hertz range. We can hear a lot more resolution. So that is why all of these charts will show more at those frequency ranges. Does that make sense? Yeah. Did I do a good job of explaining that?
I jump in with one thing.
Yeah.
So the hertz as a unit of measurement is used for frequency, but it's not used for only frequency. Hertz literally just means units per second. So hertz can mean a lot of different things. The other thing is it's literally named after a dude who's German or Austrian or something. So whenever you hear the unit hertz, that's not plural. That's literally his last name. So whether it's 1 or 10 or whatever you're referring to, it is 1 hertz or 10 hertz. It's not pluralized. It's his name.
Oopsies, I actually didn't know that. I imagine that it came from someone's name, but I didn't realize that there was the plural thing. So okay, I'm learning too. It's exciting. So yeah, the other thing to see on these charts is the dB scale over here. So dB is in dB SPL is a measure of the amount of sound pressure. This dB could be sound pressure, it could be voltage. It's just shown as dB. So this is important because this is showing the level at each of these frequencies. So one of these charts will be provided with you can find for just about any microphone that you would buy to show you the frequency response of said microphone. So as I said, because this is a Earthworks M30, which is a RTA or real-time analysis microphone, it is almost completely flat from what matters to us, which is 20 hertz to 20 kilohertz. And then it rolls off on the sides where it doesn't matter to us. It also goes up in the usable range to 30 kilohertz. I don't know exactly why, and I don't think it's particularly useful for us. But some other industries can use that data in ways that matters to them. All right. So next, we're going to look at the M30 versus a microphone that we would actually use live for a vocal on stage, which is an SM58. As I'm sure you guys know, is a very common vocal microphone. You see that while this M30 was completely flat in the usable spectrum, that this 58 is not. It has a curve to it. Also notice that this chart only goes from 20 to 20,000 or 20 to 20K instead of going from 1 to 100,000. And that's because they only want to show us, what we need to see, which is what's usable. Also notice that the scale here is different and that they show in between 100 and 1,000 with these little 2, 3, 4, 5, 6, which would be 200, 300, 400, and then 2,000, 3,000, 4,000, and so on. So this curve why does this microphone have a curve on it? So this curve is primarily there to make the microphone sound better for a vocal microphone. And this curve, depending on the microphone, is caused by characteristics of the mic in terms of how it picks up, and also is tailored by whoever designed it to pick up whatever source it was designed for better and produce the desired result out of the microphone. So this is what they found worked for a 58. When you look at all sorts of different microphones, you'll find different curves. Some large condenser, like a KSM32, tout that they're flat, which means that they would look closer to this Earthworks, but not entirely like this. Versus the Shure, which one of the great things about it is that it has that curve that emphasizes vocal presence and cuts a little bit of low mids and stuff like that. So that is why these two charts look different. Is there anything that needs to be clarified there, or anything that Josh or Kevin would like to add?
I'm doing most of my heckling in the chat, and
Oh,
I'll try and only do useful things in voice here.
oh, I put the chat in another window, so I haven't been looking at it.
It's probably for the best, to be honest.
Huh. Tailored. Yes, tailored. Excuse me. All right. So
Did you mention that the Earthworks is a reference mic? You mentioned that, right?
I did on the last slide. Yes.
Okay, great. I'll go back to sleep.
So we're gonna look at what this frequency response means. So we're gonna listen to that in Logic here. I don't exactly know how to make. One second. We're gonna reshare my screen here to my Logic window. All right. Oh, this is gonna be risky. That's what I want.
I'm sorry that we're not in webinar mode.
Oh, we're not in webinar mode?
I'm only a meeting host. I don't have webinar Zoom level.
Oh no, I'm disappointed.
I know, me too.
What is webinar mode makes it so that the participants don't have as much ability to do things like talk?
Yeah, and it sets up some better screen sharing options and like sets up Q&A stuff, and that's
yeah. My mother was on one of those yesterday for real estate related things. But anyway, so here we're looking at a recording from the UNCSA vocal test recording, which we'll listen to more in a bit, of a male singing with an M30 that's about 6 inches in front of his face. So here we're in theory capturing a pretty much uncolored sound of what his voice would sound like through this microphone. So let's listen to that.
I'd rather be sailing, yes, I would, on an open sea.
All right, so that is in theory what his voice sounds like, completely untailored and through an RTA microphone. What I should have actually done. So that begs the question, why do we have curves like the 58? Why can't all of our microphones just be 6 inches in front of the person and sound perfectly great? Well, that's not how it works out. So so microphones have these tailored curves. So now we'll listen to what a 4061 sounds like in the center of his chest.
I'd rather be sailing, yes, I would, on an open sea.
So you can hear how that sounds a lot more muffled, and it's less clear in general, and it could use some help. So here I've sort of made the response curve. Actually, I haven't listened to this from a 58 to see how that could possibly clear up what this 4061 sounds like on his chest. So now we'll listen to what this frequency curve will do to that.
I'd rather be sailing, yes, I would, on an open sea.
So you can definitely hear how that frequency curve, well, isn't the best and could be better, which is what us audio people do, makes a huge difference in how this 4061 sounds on his voice in a not ideal position. And the same can be said for a microphone picking up on stage, helping you cut through the mix, doing all those sorts of things. Yeah. So that is why different microphones have different curves tailored to what they're being used for. In terms of knowing what these different frequencies sound like and how to adjust them, if you're ever curious about sort of training your ears for that, you can find, or you can go to soundgym.co, I believe it is, and sign up for a free account and do some ear training exercises, which will help you learn how to hear those different frequencies and what the different adjustments on different sources do. But I think that that's enough for the sake of this demonstration. All right. Back to my slideshow. So here, next we're gonna go on to polar patterns, which are also called pickup patterns, and show how different microphones pick up different sound sources. So first, there's an empty one over here, and it's an empty one. And then we're looking at different microphone pickup patterns. So omnidirectional, subcardioid, cardioid, supercardioid, hypercardioid, figure eight, shotgun. All of these different patterns are designed to help you pick up what you want to pick up and not pick up what you don't want to pick up. And it's about as simple as that. And you can see how different microphone pickup patterns will pick up what you point the mic in the direction of. Apparently, I'm very scatterbrained this morning. And then you can see how these different characteristics could be useful in different applications. For example, this cardioid microphone is often used when you have a floor wedge sitting directly behind the microphone. And then in that case, that loudspeaker is projected from directly behind the microphone. Well, what if you have two and they're split from the microphone? Well, then the backwards projection may not be as useful because one wedge is here and one wedge is here. Maybe you go for a supercardioid microphone, and then those wedges would be sitting in the nodes. Or a hypercardioid microphone. You can see in these polar plots how to gain something, you sort of lose something. So with the cardioid, you see this heart shape that's pretty wide. And then in supercardioid, you can see how it narrows up some to the sides. Not by a ton in this particular drawing, but by a good bit. And then in return for that, what you get is this lobe in the back. However, the sides are tightened up, which can help you in varying situations depending on what you need. Patterns like figure eight are often meant not for rejecting things, but instead tailoring the pickup to where you want it to be. They're not really meant for rejecting things like loudspeakers. And then shotguns to us can be useful for rejecting things like loudspeakers, and then in film can be useful for rejecting background noise and giving you very directional pickup of what is directly in front of the microphone. However, you can still see how there is lobing to the sides and back. Now, these are just general polar plot examples, and a lot of microphones will do a lot better than these, but seeing these different pickup patterns is definitely useful to knowing how different microphones will pick up based on just saying, that's a cardioid mic, that's a supercardioid mic, and not necessarily looking at the spec sheet for each microphone. All right, so here we're going to look at the two frequency responses. So an M30, because it's a reference mic, is completely omnidirectional. And coming with that, the being completely omnidirectional makes the frequency response often more natural and more uniform across the spectrum, which I don't know why, but that's the trend that you tend to see in microphones. The SM58, however, is a cardioid microphone. So it's got this lobing towards the front. This is flipped over from the other one that we saw. But you can see how this is, in a lot of ways, more directional than that other picture that we saw for a cardioid microphone. However, you'll see that there are multiple lines here for both microphones. And what that's showing is the directionality at different frequencies, because the microphone is more or less directional depending on what frequency you're at. And the higher you go, the more directional it can get. And then you'll see down here, say at 125 hertz, this 58 is going towards the omnidirectional side, as opposed to 8,000 hertz, where it's a lot more directional. So all things to keep in mind. anyways, so these somehow got out of order. So this was supposed to go before. Ignore that. So now we'll look at the frequency responses from the DPA guide that show how these different placements can affect the frequency response and what that means to us. So in all cases, I believe that this was with the 4061 and a 4061 or 4060, all those series have an omnidirectional pickup pattern and are relatively flat, but depending on what cap you use, may have different tailored frequency responses. Unfortunately, I don't have a picture of that. So first we'll see on the forehead, it is relatively flat in comparison to some of the other ones that you'll see, with a good amount of level provided in this green zone, which is what's called the primary vocal range by some people, or the frequencies that are important for vocal clarity that fall in here. So there's obviously more low frequency than high frequency. A lot of this can be fixed by EQ, but that is what a forehead microphone looks like. Next, when we go to an ear microphone, you can see how much better the forehead microphone's frequency response really is. In this ear placement, there is a huge drop-off of high frequency, which can often lead to, without any EQ, the microphone sounding muffled and needing a lot of help. That's part of the reason why, if you watch the other webinar that I mentioned, using high boost caps for ear placement microphones, because that additional 4 dB of high frequency that's provided by that cap can come in here and make this frequency response sort of come back up to that zero line and more even, and sound more like that forehead placement that looked so much better in relation to this ear placement. Next, a headset. So the headset's still off to the side and sort of sacrifices some from that. However, because it's closer to the mouth as opposed to all the way back up on the ear, we're getting a little bit of that response back, specifically in that primary vocal zone, or whatever we'll call it. It's still dropping off a lot in the higher frequencies, but we're getting some back in that primary vocal range because of the headset that gets the mic closer out to the mouth. But the other difference that a headset microphone placement will provide over a forehead is that it's closer. So that can often lead to it being more direct sounding, just simply because the mic is closer to the mouth. Next is the neck placement. This placement is usually provided, well, in DPA's world, they have a little necklace microphone that's like a tube that goes around your neck that holds the microphone on your neck. This could also just be from a lav mic clipped on to a collar of like a t-shirt, as opposed to a lapel, or yeah. So there's all sorts of fun noises. So you'll see that with this one, there's a lot of this. There's a huge spike in the lower mids here, which can, or actually, oh yeah, in the mid frequency range, and that's what is essentially the under the neck sound that comes with a lot of these microphone placements, lavs, and necklace microphones. And then we see a similar drop off in high frequency to the the ear and headset microphone, but yeah, it's definitely a different response and has this sort of carve out in the middle, as opposed to just being a slope down. Then we'll look at the chest. So the chest still has this big hump for the under the neck sound, and even worse, actually, decrease in frequency in that primary vocal zone. So that's to say that all of this isn't terrible. A lot of these things are fixable by EQ, and you can make all these mics sound good. However, the different places come with different placements come with different natural characteristics that are important to keep in mind, and really useful to you if you know how to use them properly. So now for listen number 2. So I don't know if that switched right, and I'm guessing you can still see this window because it looks like it's still highlighted. But here is the UNCSA vocal test recordings part 2. I will post this link and the chat actually right now. If you want to go and listen to it on your own time, if it'll let me. Wow, this chat does not like to behave when you're on.
I can get it in the chat.
Cool. Yeah, it doesn't like to behave when you're screen sharing. So we'll just listen to a couple of these different placements and what that means in terms of how they sound. So we're going to listen to the same thing that we listened to with the M30 first, which is, and there's different files provided for each of these M30s because as they move the microphones around the face, the lav microphones around the face to capture each of those, the singers sung them just a little bit differently, so they provide the M30 reference to each of those recordings, but for all practical purposes, they sound about the same. So we'll start by listening to the center forehead one again.
I'd rather be sailing, yes, I would, on an open sea. I'd stand at the railing if I could.
All right. So we know how that sounds. And now we're going to go listen to, we'll use the 4061 as the example because I like the 4061 the most. And it's one of the flatter microphones out of the comparison here with the soft boost cap on it. And we're going to listen to that on center chest or lapel placement.
I'd rather be sailing.
So you can hear how that sounds in comparison to a forehead placement.
I'd rather be sailing, yes, I would.
Hey, Ryan.
Yeah.
Are these all the same take where they're wearing 5 different microphones in 5 different places, or is it different takes?
I know. So you can see here they did different takes moving the microphones around. Does that make sense? So they did every single microphone per take, but they didn't. The forehead was one take, the hairline was another take, the ear was another take. Does that make sense?
Yeah, that makes sense. Thanks.
Cool. Yeah, this used to just be like a download link website. So I have like a QLab file that has all of these in them that I used to use to go between them. But since then, they've created this lovely website that makes them in a much more digestible manner. And you can also download them just by clicking here and hitting download. And then you can download all of them. What else? What else would you like me to cover? How did I do?
Right now, I was wondering if you could talk about what a microphone is. What's a microphone? I like it when you don't know whether I'm serious or not. I'm not being serious. Never mind. Bye.
I was going back and forth there. I wasn't so sure. Yeah. So I mean, this is open forum for Andrew or Michael. This is for you. So how did I do? I for some reason particularly thought scatterbrained this morning. But so excuse me. I probably will not be posting this video to my YouTube as I originally planned. But please tell me if there's anything that you would like to know more about.
Just edit it down.
Yeah, I'll just edit out all of my stupid. I don't know if that's possible. There was a lot of it.
Since you asked me, thank you. I learned a lot. I thought that you explained it well, besides being scatterbrained. Thank you.
No questions? Nothing else you would like to listen to?
I was wondering if maybe you could go into Logix, like how you were earlier, and take one of those examples to like where it sounded muffled and then fix it, if that's possible.
Sure. So I mean, we saw that.
Can you fix it, Ryan? Can you? Are you able to?
No, I don't know.
We're gonna see if Ryan's any good at EQing right now.
I need to set up my
on the spot.
I need to set up my smart rig
I'm very sorry if that
And then
was an unreasonable
I
request.
have this head mount that mounts an M30 6 inches in front of their mic or in front of their
No.
mouth. And then
Wannabe, this
and
is
then I put those both into smart and I use that in tandem on every show. And I just through rehearsal rotate where that head rig goes. And then I use that and EQ it so it sounds exactly like what's coming out of their mouth. That's what I do.
this is definitely a relatively basic skill that is one of the things that you learn early, but then you practice your entire career. So
Yeah, for sure.
Yeah, you should do it, and then that way we get to hear you sing too.
Oh, you want me to sing? You do not want to hear me sing. So I'm just going to flatten this out. Recall default. And yeah, so this is an M30 center chest. A lot of times, so the SM58's frequency response has a lot of high frequency boosting. And a really important thing to keep in mind when boosting for live applications is this rule, which is called boost wide, cut narrow, which means that if you're boosting, do it wide like that. If you're cutting, maybe you could do it more narrow like this. And the reason for that is if you do this in a live application, you're going to make yourself feedback. That's just the fact of the matter because you're boosting that frequency, which is just gonna make that cycle that is feedback start. So definitely boost wide. You don't have to do it quite that wide, maybe a little bit, but definitely do not do any sort of boost like this, which some digital console will definitely let you do. Now, that's not to say that doing a boost like that cannot be useful to find a pesky frequency that you don't want, to say maybe boost, maybe a little wider like this, find it, and then cut it down. And that's a common tactic used by sound engineers when we frankly can't hear what frequency it is with our ears, or when you're trying to learn what different frequencies sound like. If you open Logic or Audacity or anything and put this file in, you could just go boost and listen to what each of those frequencies sound like, which is essentially what SoundGym will do for you. They have this game called Peak Master, and in Peak Master, it boosts a 12 dB octave wide, which is a lot wider than this. It's about that wide at 12 dB up, which would be there-ish. So it basically does that to the sound source and then asks you what frequency did we do that at. So that can be really useful in learning what different frequencies sound like and how to EQ them. Because when you know what things sound like at different parts of the ranges, you know what you need to do to make it sound like what you imagine you want it to sound like. So as a refresher, we'll listen to this 4061 center chest and see what that sounds like without any EQ.
Before you do that,
I'm sorry?
can I throw in something real quick?
Yeah.
So along with that, talking about narrow cuts, I think Ryan probably talked about in his earlier video with the intro to sound stuff how things have harmonics. So if I have a
I did
voice,
not.
oh, you didn't talk about harmonics. So
No.
think about like your voice, it is down lower ranges, 100 to 300 hertz. But if you look at a vocal mic, whenever we start things in the 1,000, 2,000, 3,000 hertz range, you're still affecting your voice and your intelligibility of your voice. That's because we hear harmonics. So a fundamental frequency of 100 hertz is going to have harmonics at multiples of that frequency at 200, 400, 800, all the way up the spectrum. So in a live application, if you go in and start hacking away at that range and you take a really wide cut, you're not only affecting those fundamental frequencies down there, you're also removing the ability of those frequencies to have harmonics higher up. So if you start with a wide cut, you can actually end up hacking yourself into a place in the spectrum that you don't want to be. The other thing to keep in mind with EQ, which is a little bit more, takes some time and kind of it's on your ears. There's this concept that physics, the wavelength and things like that really hate sharp corners and sharp peaks. So whenever we do a very tight boost like Ryan's talking about, it starts to sound unnatural. We start talking about the phase response of the EQ and the phase coherency of the EQ. So the wider that Q is, if we widen that boost out, it sounds more natural to your ears. So if you keep that Q wide in your boosts, the EQ sounds more natural a lot of times.
I just want to clarify that I was intentionally making Josh boop boop there.
All right. Well,
Can I just ask you,
I was
Josh?
moving. And I was surprised. It puts it into stream mode when I turn on OBS, but it doesn't for Zoom, which is interesting. But,
Weird. Connor had a question there.
Oh, sorry, I wasn't sure my mic was on. Josh, you were saying about the sharp peaks. Is that just a general no-no? I know this is a bit of a deviation from the main subject of today, but is that just a general no-no, the sharp peaks or sharp cuts? Is that something to avoid?
I don't have any general no-nos. It's not like something that I default to. Like I default to very wide Qs whenever I'm EQing things, just because it is what works well for me. Things like graphic equalizers that were the fundamental tool of sound reinforcement 10, 15 years ago were built on sharp peaks. So it's not a fundamental no-no. It's just not something that I default to. And
It's more a personal choice rather than anything else.
I think it's fair to say that it's more just like I'm sorry to talk for you, Josh, but just I think I can clarify that it's more just something to be aware of if you're making a sharp peak. Like just
It
just
could
sort of
affect this, and to watch out for it. Yeah.
watch out for unnatural sounds. Yeah.
Yeah. Okay, cool. Thanks.
Josh, was that right?
I also think that another thing is, so all of what this is tools and things to keep in mind in order to achieve the sound that you're looking for. But ultimately, your ears are going to tell you, does this very narrow EQ thing sound natural? Now, in terms of what we're telling you, maybe that isn't going to be the most natural sounding thing, and that's good to keep in mind before you do it. But definitely learning, none of these things do what I want them to do. Learning what those things actually do and listening to them in audio is equally important as learning the rules for this is going to, if you just learn that this is going to sound bad, maybe you'll never use it when that could be the solution to you or to your problem, if that makes sense.
I have one more question. Sorry to continue on the tangent of harmonics, like what Josh brought up, but when that's happening, how do you know if someone is singing in the 100 or 200 range, and then be able to know not to EQ out in the tens after that? Like, how do you know when they're doing that?
I think a common misconception that the disapproval of goes with what Josh was saying is you see these charts that show the fundamental ranges for certain instruments. So you'll see like a chart that shows piano uses all of this, bass guitar uses this, vocals use this much of this, horns use this. And that's just not the truth because of things like harmonics. And keeping in mind what instruments do outside of what's defined as their range is very important. I don't know if that 100% covers what you're saying, but
well, it's just like if it's like, is a singer always going to be singing at 100 frequencies, at 100 hertz? Like, is that like generally a thing?
So where I was going is that a singer's voice uses the entire spectrum. They're not just singing at 100 hertz. And you'll find that different singers, depending on their ranges, may have fundamental frequencies that exist depending on what range they sing in, higher or lower. But it's definitely important to keep in mind that people's voices do not stick to 100 hertz or stick to 200 hertz.
Exactly. So how do I know when not to EQ a certain area or when to EQ a certain area?
Did it sound bad?
Okay.
Can I jump in for a second?
Yes.
So one of the so Ryan's talking about the charts that show like the fundamental frequencies of a bunch of instruments, and they usually include male voice and female voice. But one of the things about psychoacoustics, which is like the way that our brains process what our ears hear, is that just like just like humans have a tendency to see faces everywhere because we're social creatures, we also recognize voices in a way that is far more sort of in depth than we recognize other sounds. So when it comes to voices, we talk about fundamentals and harmonics, sure, but really what it comes down to when you're talking about voices is you get sort of like the body of the voice, and you get sort of like the crispness of the voice, and you get the airiness of the voice, and those happen in sort of different frequency areas. And there's also like sort of like an area between the body and the crispness that is sort of like this. Maybe someone has a better word for it. It's when you EQ there, it starts to sound a little honky. But it's an important like part of the frequency spectrum depending. So anyway, so what I'm saying is that it's a little bit easier to talk about fundamentals and harmonics with instruments than it is with human voice, because human voices are sort of processed a little bit differently by our brains. But at the end of the day, it's still just fundamentals and harmonics, and you have to sort of you have to just go with what sounds good.
Okay.
But also like, you know, a trumpet, when we're speaking with a whole bunch of different instruments. We have our vocal cords vibrating, we have our tongue in our mouth affecting that airflow and also making percussive sounds in our mouth. And then we also have our lips at the front of our mouth stopping the airflow and making percussive sounds. So actually our voices are sort of a bunch of different instruments working in together. So that kind of affects the way that you hear things differently. One sort of comparison is with percussion instruments, including piano and also like kick and snare and whatever, is you have sort of different frequency responses depending on if you want to hear the crack of whatever's hitting the other thing, whether it's the hammer hitting the string or the stick hitting the head of the drum, and then you have a different frequency response for the resonation of the instrument.
Yeah, totally.
So this is the I found all of the different charts I'm talking about. So so this is one of the examples of one of the charts. My mouse is acting up. One of the charts that I absolutely don't like.
Do you need me to help you with that? Because I'm an expert at dealing with mice that are acting up.
Well, if you want to fly all the way to Raleigh to fix my mouse, although I feel like it would be cheaper for me to just buy a new one. Just saying. Although flights are really cheap right now, so who knows? Anyways, so vocals, this is showing like, hey, vocals male only go from, what's that, 100 or 170 hertz or vocals female to 2000 hertz. What? That's not true. These are the charts that I like more. So here's one from Sweetwater, and what this shows is not that these instruments exist I don't think it has vocals. It doesn't have vocals. Exist in these certain ranges, but where the characteristics of those may exist. So it's saying this exists in the entire spectrum, but for a snare drum, the girth is here. The boxiness is here. The bark is here. So those are all, keep in mind. And then charts like this that show that this is sort of in between, that the fundamental of the voice may be here, but that the harmonics exist here, which goes with what Josh said. So definitely be mindful in charts like this that things don't just exist from here to here. That's just the fundamental.
I might just step in for a moment.
Yeah.
I think it's most important to understand the human voice is not like another instrument. Every voice is very different.
Yes.
You can't chart a human voice and say it's the same for all voices. And it's important to understand that you don't have to put a lot of EQ on every voice just because someone told you it needs a lot of EQ. I stepped one time into a professional musical theater show, and I saw the most horrific EQs that I ever saw, and I had to delete everything and start new. If I find something, I will share it in the chat, but don't put too much thought into voice EQs before you have the singer for it. You have to listen and find what works for the individual voice, and there is no chart that can tell you what will work for each person.
Now, going with that, there's a lot of the way that musicals or bus and designers work involves certain bus EQs on, say, a vocal bus that are sort of applied general settings that allow a starting point for all of the vocals, which oftentimes are not there to make a voice sound different. They're there to adjust for microphones or PA systems that don't sound natural. And then that's another thing to keep in mind, that with EQ, you're not correcting the voice necessarily. You are, which is, I mean, you can do some corrections. If someone has a nasally sounding voice, you can definitely take some of that out with EQ. But a lot of what we end up EQing in live applications is to make up for our PA systems and our microphones, not to change characteristics of voices, to better replicate those characteristics. And I feel like most people here could agree with me on that one.
Yeah, definitely.
Will you go back to that Sweetwater chart for just a second?
Yeah.
The only thing I would add is there's a component that we haven't really talked about yet that is called masking, which if you look at where some of these things exist, like the guitar and the piano, that presence is overlapping in the same region. If you look down, the vocals are kind of in that same region. So if I need a lot of presence in my piano and my acoustic guitar, they're going to be overlapping in regions where vocal presence usually happens. So part of my EQing may be to take some of that out in the acoustic guitar, in the piano, because it's muddying those vocals. I was working on a show that had a systems engineer that was EQing the band for a musical, and the mixer came out and said, hey, the band sounds a little bit dark today. Do you know what's going on? Maybe you can try and brighten that up a little bit. And he had a filter on one of his EQs. He said, watch this. And he opened up that filter, which took out a cut in that 2 to 3K range on the band. And the mixer was like, oh, that's it. It sounds great. And then the actors came out and they started doing vocal sound checks. And he came over and he was like, man, I'm really struggling to hear the voices today. The vocals aren't sitting well with the band. And the systems engineer turned to me and said, here we go. And he turned that filter back on, making that same cut from earlier where the band was too dark before. But since the vocals were in that region now, it was right. And so everything kind of fit in the right place once he got the vocals in. So keep in mind that we talk about the science behind this and the math and the frequency and the overtones and all of that, but really it comes down to what sounds right. So some of it is you have to know the math, and here's a good chart of some frequency ranges and stuff, but some of it is, okay, what am I hearing in the vocal? What am I not hearing in the vocal? What do I need to change? More than what are the rules? Like, what is the right way? Like Michael was talking about, there's not a set way to do this right. There's not set numbers necessarily to start out with that you look for until your ears are comfortable and you kind of know where to go.
I think that with that, yes, EQs like that. We can talk about what the EQ that Michael just sent actually does as well. But where's I going? I mean, as a sound designer, as musicals are getting more and more poppy and less dark and old, this is definitely a struggle that designers have, is that people want the band to sound very poppy and bright and there, but also the vocals to sound the same way. So how to work and balance those is definitely an acquired skill, and it's something that people work a long time to know how to do. So, yeah. Let's talk about what Michael has. This picture is a picture of a terrible, well, maybe not necessarily terrible EQ, but what this EQ is really doing is level reduction. I mean, you can see that all of these cuts are happening. However, really, where they all overlap, which is around negative 5 dB, it's cutting everything negative 5 dB, and then it's doing these additional cuts at certain frequencies. So when you get into doing a lot of EQ, and actually, I never even realized. So on the Allen Heath, this yellow line shows the summation of all the EQs. So really what this EQ is doing is more like an 8 dB or 9 dB level reduction. And then below that, it's actually doing some EQ. So definitely be mindful never to work yourself into a world in which you're using your EQ to reduce level, and then you're doing some creative EQ changes, because that can create a lot of problems for you with gain structure, with gain before feedback, with lots of things. So definitely try not to do that. All right. So let's EQ this vocal. So we'll listen to it again, just flat.
I'd rather be sailing, yes, I would, on an open sea.
All right. So the first thing that I do to most of my vocals, especially musicals, every vocal that I ever do is I put a low cut filter on it, high pass filter. Oftentimes in my console programming, I'll start that, and that will be usually the only thing that I put into the console EQ wise before I show up and load that file and hear people through it. On a single channel will be that low pass. So for him, I'll do it around 140, and then we'll listen to how that cleans it up.
I'd rather be sailing.
Versus.
I'd rather be sailing.
So.
Is it just me, or does it sound like it's coming out of your speakers, Ryan?
Oh, did I? Sorry. When I restarted the share, I probably didn't.
Yeah, that might. Yeah.
I probably didn't click the. No, I hit share computer sound. Here, let me put on. Let me grab a pair of headphones so you're not hearing it.
Ryan, check your input and logic too. I think your microphone is set as the input.
Yeah, my microphone is the input for input 1. Yeah. Actually, it's not. It was before, but it's not anymore. Yeah. So, tell me if you guys can hear this. Could you hear that?
No, it's completely gone.
So you've just okay. Well, let me figure out, because I have Zoom with the checkbox share computer audio, but I don't know exactly what that's doing. Advanced.
Is your default device the Focusrite?
It is. Music or computer sound only. No, I want. This whole time I thought that the Zoom audio would be working great and that you could hear.
It was at first.
Oh, it was working before?
It was working before the screen. Yeah, I'm pretty
sure. Yeah,
yeah, it was fine for me.
Yeah, I agree.
Well, here, let me just try stopping and restarting them.
Cool.
Well, I am a really good singer. Thanks, Jack. Output. Oh, that's how it does it. I know it's wrong. So I don't know if I will still be able to hear. How is that?
Yeah, that's it.
It's back.
So Zoom just creates a virtual output device. So so when I was in Chrome, it was outputting out of my system audio, which was the Zoom virtual output device, but in Logic it had not adhered to that. So right, so I have this off. We'll listen to it flat again.
I'd rather be sailing, yes, I would,
On an open sea.
All right, great. And then we're going to put on this this low pass filter. I'm sorry.
Probably go ahead and
I am
turn
so scatterbrained. I'm sorry.
You can probably turn it back down a little bit too.
Oh, all right.
I'd rather be sailing, yes, I would. On an
So can you guys hear the difference that made?
It's not much, but it cuts out a lot of the low kind of fuzz background noise. A lot
Yeah.
of the time.
Yeah.
And that's something that's harder to hear on laptop speakers or but when you have that running through a PA with
It's very obvious.
with
yeah.
lots of components, yeah. And especially the rumble, like this is a very clean room that was recorded in. It was recorded on a completely empty soundstage. That's I believe 100 by 150. So in a theater, it's a bit different. So we're going to listen to actually a boost of what this sort of low range sounds like.
I'd rather be sailing, yes, I would.
So a lot of times what I end up doing to get clarity is doing a low mid frequency cut as opposed to a high frequency boost. So on a lot of my vocals, I will start with a cut around 250. And as before, that affects a lot of things, but that's what I've found works for me to start cleaning it up. And a lot of times I do that cut on so many things that I'll end up translating a cut like this to my vocal group. But cuts like this also depend on how your system's EQ'd. So keep that in mind.
I'd rather be sailing, yes, I would. On an old.
All right, so that cleaned it up some and made it a bit more present. And but there's a little bit of maybe higher mid frequency sort of maybe nasally sound that we might want to try and get rid of. So what I'm going to do is I'll do it with this filter actually. I'm going to do a boost and sweep, and we're going to listen and find that nasally frequency.
I'd rather be sailing, yes, I would. On an open sea, I'd stand at the railing if I could. Feeling wild and free. The sun is on my neck, the wind is...
All right. So could you guys hear how around 1K there was some nasaliness and some not amazing things?
Yes, 100%.
Yeah, I did. Thank you.
So I did cut there. And you can sort of continue down this road of making it sound clearer and clearer. Yeah, I feel so weird in this environment EQing in Logic with other people watching. I don't know why. I've never had other people other than Brandon watch and closely criticize my EQ choices. But yeah, that's sort of the process, and I'll probably continue into a little bit more low mid frequency.
You're just gonna leave it there. You're not gonna make it sound good.
I don't like EQing the people watching, Kevin.
Can you
Kevin, this is why he's uncomfortable.
Yeah,
I know. I'm helping to encourage that. You should do an example that lets us hear a little bit more presence up in like.
Yeah.
That's definitely what it's missing, and like.
Yes.
Like presence is sort of. I very rarely will boost at all, but presence is one place that I will sometimes boost a little bit.
So let's talk about the well, we'll talk some about what can happen in this high frequency range. So a lot of times around 3-4K, you'll find that things can be, if boosted too much, can be maybe painful or very like harsh PA sounding, especially in that like 4K range. So from when I boost for presence, I try to avoid this 3-4K range. I don't know how how other people feel about that, but that's typically what I do. And then I find myself cutting some of that on things like electric guitars and stuff to reduce some of that harshness. So we'll do another play, and I'll sort of sweep across the high frequency spectrum, and then we'll decide where we want to boost in order to get that clarity.
I'd rather be sailing, yes, I would, on an open sea. I'd stand at the railing if I could, feeling wild and free. The sun is on my neck, the wind is in my face, the water's in...
I don't know. I feel like it's not doing an inherent ton amount.
This is the chest mic, right? I mean, that's
Yeah.
going to need a ton of high-end boost. Like,
I-
we'll go back and
yes.
look at your document, and it's
Yes.
look at the see what
It's
frequency
true.
that giant dip is.
Huh.
I was
just
hearing
feel
a
like-
pretty decent.
Yeah. I'm sorry.
I was hearing a pretty decent improvement. Like around like 7K, 8K.
Yeah. No, I don't know. I just felt like I don't know. Like it wasn't doing a ton, but as you said, that's because it's a lapel mic.
terrible microphone placement. Yes.
Yes. And I'm like so used to EQing forehead mics and ear mics that I'm like, what the hell is happening? Anyways, so we have a bit of a boost here. That is, I hate how Logic shows the right one on the other side. So we did about a 4 dB boost there. And I'm also going to do a bit more low mid frequency cutting, which is another thing that cutting low frequency can boost high frequency in sort of an adverse effect. So we'll listen to this.
I'd rather be sailing, yes, I would, on an open sea. I'd stand at the railing if I could, feeling wild and free. The sun is on my neck, the wind is in my face, the water's incredibly blue.
All right.
I think I just realized that I have a little bit of like, what's that thing? Is it synesthesia, where you translate one sense to another? Because I kept thinking that I wanted more salt in that vocal, which is, I think, how my brain translates presence in vocals. I need more salt. Yeah.
So you think of it as, all right, that's interesting. I never thought of it like that.
Will this be similar to the time some bass guitarist asked me to make his mix sound more purple?
Yeah, totally. I mean, for some people, that's a real thing. Like
Yeah,
that they,
color.
That they.
Yeah, I know. Yeah,
Well, 'cause, like,
sometimes
for
I
a
get
lot
it
of
too.
people, like like purple
The
will
mix
be
is sounding
like a
blue
mix
today.
of like blue is often well, like
Kind of like darker sounding.
yeah, darker, sometimes a little harsh, and then purple is like warmth. Also
Mellow.
orange is warmth. Yes, purple is definitely mellow. No, like totally one of the big challenges of like the sound designer is figuring out terms that communicate things like like as sound people, we're always trying to find terms like things like brightness and warmth and dark and
Things to help describe it, yeah.
yeah, that's like
Descriptive.
something that we're constantly doing. Yeah. All right. I don't know. I feel so. It's just for some reason this whole thing feels so weird. Let's go through and actually do this for a 4061 in a much superior placement. So that would be male singing center forehead. All right. So we'll listen to that dry to start.
I'd rather be sailing, yes, I would, on an open sea. I'd stand at the railing if I could.
So you could hear what happened when I dropped in that that high pass filter, and how this sounds a lot brighter just to start because this is a forehead microphone placement. So listen back to that again, and I'll put in some EQ cuts, and then we can see what that does.
I'd rather be sailing, yes, I would, on an open sea. I'd stand at the railing if I could, feeling wild and free. The sun is on my neck, the wind is in my face. The water's incredibly blue, and I'd rather be sailing. Yes, I'd wanna go sail and then come home to you. Sex is...
All right, we'll keep out of the not safe for work part.
Can you play it once and then turn off and on the EQ to hear the difference?
Yeah.
I'd rather be sailing, yes, I would, on an open sea. I'd stand at the railing if I could, feeling wild and free. The sun is on my neck, the wind is in my face. The water's incredibly blue, and I'd rather be sailing. Yes, I'd wanna go sail and then come home to you.
All right, we're skipping the sax. So, could you hear what difference that was making?
Yeah, I definitely heard a lot of the lows getting cut out a little bit and made it sound a little more like up there.
Open,
I don't know.
detailed.
Present.
Yeah, present.
Definitely a lot more present.
It's
Salty.
salty, yeah.
It is, yes.
We've assaulted our vocals.
So
No one likes my joke. It's all right.
I loved
It's all
it.
right.
Thank
I
you.
do it.
I laughed,
Yeah.
but I
I
was
did laugh.
muted.
one thing to
Thanks,
When-
guys.
that Brian kind of touched on earlier with the crazy looking EQ curve on the Allen and Heath is that EQ is making gain adjustments to your overall signal. So like here, this literally is attenuating the gain of the signal by 8 decibels. So we can't really trace like a flat line on the EQ curve that Ryan made as to how much the gain is being attenuated. But keep in mind, there is that constant battle of gain before feedback. And whenever you start making cuts, you put yourself in a better position to be able to boost that microphone up in volume if you need to. If Ryan were to go the opposite way with this EQ curve and were to turn up the things he wanted instead of turning down the things he didn't want, he would put himself in a much worse situation in a live situation for feedback.
Yeah, I'm trying to think of a good way to show the in and out gain, but I don't think that this EQ shows in and out gain. So I can't really show that. You will see that this EQ has a gain adjustment. And that's actually fun, what this gain adjustment shows and does. So this is actually a good thing to relate back to that Alan Heath EQ. So so you'll see here that look at that yellow line specifically, which is showing the summation of those 4 EQ bands. And that yellow line doesn't show the high pass filter, but imagine that it's getting cut off in that around 100. So so you can see how these EQ cuts have summed to that. So here, these little EQ cuts or these little EQ adjustments that I've made are doing that. And I made them a little less little. They're doing about 5 dB, 3 dB, 4 dB. But this, doing that, is essentially what this EQ is doing. It's still sort of translating those cuts into the curve, but it's overall reducing the gain of that signal. And there are reasons that you'll figure out from a practical sense of how that is bad for both your gain structure and your and your gain before feedback. There's also phase implications of making changes like that. I don't think I have on my new computer I don't have Compass, but one second, let me download Compass, because Compass has the best graphics to show what these gain changes are making.
Also, if you go in and duplicate that track and bypass the EQ on one of them in your metering down on the bottom, you'll be able to see how the EQ.
Oh, that's true. Let me do that. While Compass is sorting itself out, I will duplicate that track. Oh, that's not how you do that. Maybe I'm not as versed in Logic as I thought I was. Come on. Be nice to me. Come on. Watch Ryan struggle with Logic. A 4-part video. All right. So we'll look at the metering on all of these and listen to the EQ one.
I'd rather be sailing, yes, I would, on an open sea.
So the adjustment that I did there was just to simulate what it would be like if I made that massive EQ dip.
I'd stand at the railing.
So you can see how that's affecting overall signal. So let's look in Compass, because one of the great things about the Meyer stuff is Compass. We'll skip verifying that and risk hurting my computer. Come on, hard drive, be fast. That really should be faster. It's weird. All right, there we go. So Compass is, for any of you that don't know, is Meyer's control application for all of their live stuff. I do not need to do ABB. So it allows you to control Galileo Galaxy and do monitoring of the loudspeakers. So let me make this virtual. Galaxy One. So in the EQ section here for these processors, this is just a basic EQ. We'll actually go to an output EQ. There we go. So so you can see here that as I do this EQ boost or cut, this line here is showing what that's doing to phase response. So if I do 3 little cuts like this, 1, 2, 3, or even 4, that's what I'm doing to my phase response. If I do this, that's what I could be doing to my phase response. So doing crazy cuts can definitely do things. Also, as you do narrow cuts, you are affecting the phase response more. So if I do something which is in fact very similar to what they did on that Allen Heath, I'm doing that as opposed to doing this to my phase response. So you can see the huge difference that makes in things like phase response, which can play a key role in stuff that frankly is sort of past what I really technically understand and can explain well. I don't know if Josh's fancy Belmont education can help explain how that impacts your mix more. But yeah. And anything else? Oh.
That was great.
Great.
Round of applause, please.
Sound. Woo! Yeah.
We can do it.
The polarity response.
I'm sorry, what was that?
Will you talk about how polarity response and phase response are the same thing?
Oh my God.
Oh, not again.
You already asked me this. I don't have that Max demo on this computer. I'll have to go re-download it to explain it to you again, Josh.
Don't do it, Ryan. Josh is baiting you.
I know. Well, now I have Compass because I'll definitely communicate with the Galileo from my iMac. I do want to buy a Galileo. I've been hounding them on eBay, but they're like $2,500, and I don't want to spend $2,500 on a processor for obvious reasons. All right. Is there anything else that we can, the collective mind that is Kevin, Josh, and I, help address or answer for you guys? All right.
I had something earlier, but I forgot it. So yeah, I'm good.
Well, I'm happy that my babbling got you and my awkwardness got you away from your question. I hate this bar that Zoom has. It always gets in the way. All right.
You can move it.
I did. I just moved it to the bottom.
Okay.
Can I move it over here? No, it's just top or bottom. All right. Well, we know that I'm a bottom, so.
Okay. Well, I'm just going to end this meeting then.
There we go.
Great job. Okay. Bye,
Nice
everyone.
stuff, lads.
Clap, clap, clap. Good job. Thank you.